Now we're going to look a little bit more closely at the idea of a conditional and some of the alternative ways that it can be represented, just so you can identify them when they appear. Conditional statements, remember the if-then combination. We symbolically represent them with the one-way arrow. And here I have an example of if I fly on a plane, then I wear a mask, right? So that's a requirement for being on a plane, is that you wear a mask now. And so the two parts of that sentence or statement, P is I fly on a plane, Q is I wear a mask, right? So those are the two simple statements that we're now combining into a compound statement, okay? So now let's look at all these different ways of saying that are all really equivalent to each other. They're just alternate ways of phrasing it. So if P then Q, that's the original here. If I fly on a plane, then I wear a mask. P implies Q, so flying on a plane implies that I must wear a mask, okay? Q if P, I wear a mask if I fly on a plane, right? That would be an alternate way of stating it. P is sufficient for Q. That's kind of an interesting idea, the idea of a sufficient condition. So in this case, flying on a plane is sufficient for wearing a mask. Okay, so if you think about all the different places you wear a mask, flying on a plane is one of them. It's sufficient for wearing a mask. Q is necessary for P, meaning wearing a mask is necessary for flying on a plane, which is true. It's a requirement. So things that are requirements would fit that, very nicely. P only if Q. I fly on a plane only if I wear a mask, right? They'll kick you off otherwise. And only if Q, P. So only if I wear a mask do I fly on a plane, right? And all those kind of make sense once you put it to an example. As you're looking at it here in the formal way, maybe they don't appear necessarily to be the same. But all of these statements then are exactly the same. They're equivalent to the original if P then Q. And you can kind of get a sense for that when we put it to an example. Now I have mentioned before the idea of subsets, or sets, the P and the Q, these statements representing sets. And so in this example, or actually in general, if P and Q describe sets A and B respectively, so P describes A and Q describes B in some way, then A is a subset of B, all right? So this implication or this conditional statement really describes a subset idea. And so in this particular case, if you think about set A, set A is the set of all people X, such that X flies on a plane, or is flying on a plane. Okay. And then you consider the set B to be all the people wearing a mask, right? So X such that X is wearing a mask. So P describes the set A, Q describes the set B. Well, it turns out that of all the people wearing a mask, those flying on a plane are a subset, right? So you'd have, in some sense, the universe is all people. That's all people. Then the ones flying on a plane are, let's say they're here. That's all the people flying on a plane. Then the ones wearing a mask would be what I would call a superset of that, right? So the ones wearing a mask would include the ones in a plane, but they'd also include other people. Like myself right now, right? So you can see how there are going to be elements of B that are not necessarily in A, but all of A must be in B. Okay. So you have this subset idea, pretty obviously. Okay. Now a biconditional statement is where the subset goes both ways. Kind of interesting. So think about that. Let me get rid of some of these here. For a biconditional, that's the P implies Q and Q implies P, or P if and only if Q. You have the subset going both ways. You have, whoops, you have A is a subset of B and B is a subset of A. Well, if both of those are true, then really the two sets must be equal, right? So just a kind of an interesting representation how this applies to a biconditional as well.